On April 1st, 2026, 4 astronauts left Earth and began the longest journey any human being had attempted in over 50 years. Reid Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen flew toward the moon, towards something hiding a scar so large, so violent, and so old that most scientists still cannot fully account for it. It nearly ended everything. Not the mission, not a program, everything. Every organism on this planet, every tree, every ocean, every ancestor you have ever had. The South Pole Aitken Basin, a formation carved into the moon roughly 4 billion years ago, is the reason you exist. And we are only beginning to understand what created it. We talk about the moon as a companion, a fixture, something peaceful in the sky. But the moon is not a companion. It is a shield. And the South Pole Aitken Basin is the largest wound it ever took protecting us. That wound is 2,500 kilometers wide. It is 8 kilometers deep in places. If you placed it on Earth, it would cover the entire continental United States and still spill into both oceans. We had no idea it was there. For most of human history, the South Pole Aitken Basin did not exist in any map, any theory, any scientific record. It sits on the lunar far side, the hemisphere that never faces Earth. We could not see it until we sent something around the moon to look. When Soviet Luna probes first captured images of the far side in 1959, what they returned changed everything we thought we understood about what the early solar system was capable of doing. 4 billion years ago, the solar system didn't look anything like it does today. It wasn't quiet. It wasn't stable. It was chaotic, more like a shooting gallery than a system. Asteroids the size of small countries were crossing planetary orbits constantly, colliding with anything in their path. These weren't rare events. They were happening over and over again, on timescales that are honestly hard to wrap your head around. This period is what geologists call the late heavy bombardment. And the moon, unlike Earth, kept the evidence. It has no atmosphere to burn incoming objects, no plate tectonics to recycle its surface. So every major impact, every collision, every violent moment from that era is still there. And one of those impacts was different. Whatever struck the moon's southern hemisphere wasn't just another asteroid passing through. Scientists have reconstructed the event by working backward from what it left behind. The size of the basin, the depth, the amount of crust that was displaced. And when you actually look at those numbers, they're hard to ignore. The object that hit the moon is estimated to have been somewhere between 170 and 320 kilometers wide. For comparison, the asteroid that wiped out the non-avian dinosaurs 66 million years ago, the Chicxulub impactor, was only about 10 to 15 kilometers across. This was 20 to 40 times larger. And that difference isn't just big, it's transformative. Because when something that size hits a rocky body at orbital speeds, roughly 15 to 20 kilometers per second, the physics stop behaving in ways we're used to thinking about. It's not just an explosion, it's a release of energy so extreme that even scientists struggle to describe it in everyday terms. Planetary scientists like Peter Schultz at Brown University, who has spent decades studying high-velocity impacts, have modeled what this collision would have looked like, and the scale of it is difficult to overstate. Rock wouldn't just break, it would vaporize instantly, across an area larger than Western Europe. A shockwave would travel through the entire moon, not just the surface, but deep into its interior, permanently altering its structure. And the material that was ejected wouldn't just fall nearby. It would be thrown hundreds of kilometers into space before coming back down across the surface. The crater that remained is not a hole in the conventional sense. It is a depression so large that standing at its center, you would not be able to see its rim. The basin sits below the local lunar horizon. It has its own mountain ranges, its own plains, its own subsidiary craters, formed by billions of years of subsequent impacts. It is not a feature on the Moon, it is a region of the Moon. Scientists named it the South Pole Aitken Basin in 1962, after the two geographic features that mark its outer boundaries. It remained poorly understood for decades, simply because of where it sits. No human being has ever seen it directly from orbit. No mission has ever landed inside it. That has now changed. The crew of Artemis II captured images of the South Pole Aitken Basin up close, documenting the structure in detail in ways never done before. In 2019, NASA's Grail mission, two spacecrafts flying in formation and measuring minute changes in each other's orbit velocity caused by variations in the Moon's gravity, detected something that had no business being there. Beneath the floor of the South Pole Aitken Basin, buried deep within the lunar mantle, is an anomalous mass concentration roughly 2.18 quintillion kilograms heavier than the surrounding material. A dense region of something hundreds of kilometers wide, embedded in the Moon's interior, at the exact depth where the original crust was stripped away by the impact. The leading explanation, published by Peter B. James of Baylor University and colleagues in the Journal of Geophysical Research Letters, is that this mass is the metallic core of the impactor itself. The object that struck the Moon may have been a differentiated body, meaning it had already separated into layers internally, with a dense iron-nickel core at its center. When it hit, rather than fully vaporizing, that core partially survived and sank into the lunar mantle, where it has remained for 4 billion years. The impactor is still inside the Moon. It never left. This is not a detail without consequence. The mass anomaly is large enough to have measurably altered the Moon's center of gravity. It affects how the Moon rotates. It affects the tidal forces between the Moon and Earth. An object that struck our companion world 4 billion years ago is at this moment still shaping the physics of the system we live in. If it had hit Earth, the Chicxulub impact 66 million years ago ejected enough debris into the atmosphere to block sunlight globally for years. Temperatures collapsed. The food chain collapsed. 3/4 of all species on Earth died. That impactor was, at most, 15 kilometers wide. The object that created the South Pole Aitken Basin was between 170 and 320 kilometers across. The energy released by Chicxulub is estimated at roughly 100 teratons of TNT. The SPA impactor released energy orders of magnitude beyond that. Some models place it in the range of billions of nuclear weapons detonated simultaneously across a single continental scale zone. An impact of that scale on Earth would not have produced a mass extinction. It would have sterilized the planet. The impact energy alone would have vaporized the oceans, not evaporated, vaporized, and ejected the resulting steam and rock into space. What returned would have been a rain of molten debris covering the entire surface. The atmosphere as it existed would have been destroyed. Any life on Earth at that time, and there was microbial life, primitive but present, would have been extinguished completely. The Moon took that instead. This is not a metaphor. The geometry of the early solar system meant that the inner planets, including Earth, were targets. The Moon, orbiting close enough to intercept certain trajectories, absorbed impacts that would otherwise have reached us. The South Pole Aitken Basin is the largest confirmed example of that interception in the geological record of the Earth-Moon system. The Moon did not choose to protect us. Physics chose for it. But the result is the same. We are alive, in part, because something hit the Moon instead of us. Wiseman, Glover, Koch, and Hansen approached the Moon that hides all of this. Their trajectory took them around the lunar far side, the hemisphere where the South Pole Aitken Basin sits. For 40 minutes, they lost all contact with Earth. No signal in, no signal out. They became the human beings physically closest to the largest confirmed impact structure in the solar system. They did not land there. Artemis II was a crude flyby, designed to verify that Orion functioned correctly with humans aboard in deep space. But the missions that follow are already designed with the South Pole Aitken Basin as a destination. Artemis II is planned to land near the lunar South Pole, within the outer edges of the basin itself. The water ice confirmed in permanently shadowed craters at the South Pole, craters that exist because of how the ancient impact reshaped this terrain, is the primary reason NASA chose that landing zone. The water that will sustain future astronauts on the lunar surface exists because of where that impact occurred 4 billion years ago. The crater is still providing for us. The South Pole Aitken Basin did not begin as a scientific mystery. It began 4 billion years ago when something the size of a small continent fell out of the sky at 20 kilometers per second and carved a hole in the moon that has never healed. It began in a solar system still violent enough to move mountains between planets. It began when an object 20 to 40 times wider than the asteroid that ended the dinosaurs crossed the moon's orbit and did not miss. It began when a world that could not protect itself absorbed the impact that might have ended ours. It began in the permanently shadowed craters of the South Pole, where water ice thrown up by that ancient violence has been collecting for billions of years, waiting for us to arrive and use it. It began every time we looked at the moon and thought we understood it, and the moon kept its deepest secret on the side it never showed us. It saved us. Planetary scientist William Hartmann, who first formally modeled the giant impact hypothesis for the moon's formation back in 1975, wrote that the moon is a window into the early history of the solar system. He was right, but it is also something else. It is the thing that stood between us and the early solar system long enough for us to survive it. A protector we never knew we had. 4 billion years old, still there, still working. And this is just one discovery in a universe full of mysteries. Thanks for watching, and I'll see you next time.